Towering mountains of ice, ancient rivers frozen in time. Glaciers are some of Earth's most breathtaking natural wonders. But how much do we really know about them? Today, we're climbing up into the frozen world of glaciers to uncover their secrets, their power, and their vital role on our planet. In today's video, we're exploring glaciers, how they form, where to find them, and why they're so important. What are glaciers? Glaciers are massive, slow-moving rivers of ice. To put it another way, they are a very large, thick mass of ice that stays frozen from one year to the next and has the ability to move. They form in areas where snow doesn't completely melt in the summer, allowing it to accumulate year after year. Over time, the weight of the snow compresses it into dense ice. Although they might seem stationary, glaciers are constantly moving. Some move only a few inches per year, while others can flow several feet daily. Have you ever seen a glacier? Glaciers are found all over the world. Since glaciers are made of ice, it makes sense that they would form in colder places. Most are located in polar regions. Antarctica has a ton of glaciers, with about 90% of the Earth's glaciers being located on the continent. Despite the name, Greenland is not very green. It is actually the second largest glacial region, with 8% of the world's glaciers being located in this country. The rest of the world's glaciers are spread out in different places. Would you like to go to Antarctica to see the glaciers? Let's learn about some famous glaciers. I do apologize if I say these names wrong. Did you know there are glaciers in tropical areas? The Pastoruri Glacier in Peru is located in the Andes Mountains and is one of the few tropical glaciers. You can also find them in high mountain ranges. The Khum-bu Glacier in the Everest region of Nepal is a popular spot for mountain trekkers. This is the highest glacier in the world, starting near the peak of Mount Everest. One of the most accessible glaciers is the Athabasca Glacier in Canada. It's part of the famous Columbia ice field. You can even take a tour and walk on it. The Lambert Glacier in Antarctica is the world's largest glacier, stretching over 400 kilometers or 250 miles. One of the fastest moving glaciers is the Jakobshavn Glacier in Greenland. If you want to see some cool ice caves, you can check out the Mar de Glace. It is located in the Mont Blanc Massif and is the longest glacier in France. The Hubbard Glacier in Alaska is North America's largest tidewater glacier. It is famous for advancing instead of retreating, creating natural dams. When you think of a rainforest, you don't often think of glaciers. However, the Fox and Franz Josef glaciers are located in Laurentide National Park near the rainforest. Volcanoes can also have glaciers, as is the case with Europe's largest glacier by volume, Vatnajökull Glacier. This glacier is well known for its volcanic activity beneath the ice and its stunning ice caverns. Can you believe that people would fight over a hunk of ice? Siachen Glacier in India is the world's highest battleground, as it is located near a disputed border. It is also one of the largest glaciers in the Himalayas. Each glacier offers its own story about the Earth's climate, geology, and history. Have you ever seen any of these famous glaciers? If you know how to pronounce these right, feel free to correct my pronunciation in the description. I'm sure I butchered several. One famous glacier I haven't mentioned yet is the Perito Moreno Glacier. It is located in Los Glaciares National Park. Why is it famous? It is one of the few stable glaciers in the world. It also has dramatic ice calving events. But what is ice calving? Ice calving, also known as glacier calving, is the process where chunks of ice break off from the edge of a glacier or ice shelf. These pieces of ice are called icebergs. They fall into a body of water, such as a lake, ocean, or fjord. But how does this happen? As glaciers flow towards the water, the pressure and weight of the ice can cause cracks and fractures to form. When the glacier's edges extend into the water, the buoyant force of the water can lift and weaken the ice. Waves and warmer temperatures often erode the glacier's base, further destabilizing it. Eventually, gravity takes a toll. The weight of the ice and the internal fractures cause large chunks to break away. Ice calving doesn't just happen in the summer. It can occur year-round. Ice calving most often occurs in tidewater glaciers that end in the ocean or sea, ice shelves that have massive floating extensions, and in small glaciers that end in freshwater lakes. When ice calving happens with land-based moraine-based glaciers, or ice sheets, the released icebergs contribute to rising sea levels as they melt. Increased calving events can indicate that a glacier is retreating due to warming temperatures. Many people like to witness these events for the dramatic crashing sound and sight of icebergs splashing into the water. As you may already know, water can dramatically shape the land. Glaciers are powerful forces of nature. As they move, they carve out landscapes, creating U-shaped valleys, fjords, or even entire mountain ranges. The rocks and debris they pick up along the way create features like moraines and eskers, which geologists study to learn about the Earth's past. Even when they melt, glaciers leave behind clues about their journey. Glaciers sculpt a variety of stunning landforms that reveal their immense power. An arête is a sharp, narrow ridge formed when two glaciers erode parallel valleys, often found in high mountain ranges. A crick is a bowl-shaped hollow carved into a mountainside, marking where a glacier once began its journey. A glacial trough is a U-shaped valley formed as a glacier erodes and widens a pre-existing river valley. In contrast, a drumlin is a streamlined oval-shaped hill made of glacial debris, shaped by the movement of ice sheets. Eskers are winding ridges of sand and gravel deposited by meltwater streams flowing beneath a glacier. Often, features like moraines are accumulations of rock and debris at the glacier's edges, whereas fjords are deep, glacially carved valleys filled with seawater that further showcase the diverse landscapes created by glaciers, each telling a story of their icy past. One of the most famous fjords in the world is Norway's Gei-ranger-fjord, renowned for its stunning cliffs, cascading waterfalls, and deep blue waters. This fjord is a UNESCO World Heritage Site that was formed over 10,000 years ago during the last ice age, when massive glaciers carved through the landscape. As the glaciers advanced, their immense weight and movement gouged out deep U-shaped valleys in the bedrock. When the climate warmed and the glaciers melted, seawater flooded these valleys, creating the dramatic fjord seen today. Gei-ranger-fjord stretches 15 kilometers or 9 miles inland and reaches depths of over 250 meters or 820 feet. Surrounded by towering peaks and lush vegetation, a testament to the power of glacial forces in shaping our world. The Great Lakes, a vast freshwater system spanning the US and Canada, owe their origins to glaciers from the last ice age. Around 14,000 years ago, massive ice sheets such as the Laurentide ice sheet advanced across the region, carving out deep basins in the bedrock. As the climate warmed, the glaciers began to retreat, leaving behind meltwater that filled these basins, forming Lake Superior, Michigan, Huron, Erie, and Ontario. Today, the Great Lakes hold 20% of the world's freshwater and stand as a testament to the power of glaciers to shape our planet's landscapes. Have you ever seen one of the Great Lakes? I've seen Lake Erie a few times because I used to live not too far away from it. I also saw Lake Michigan when I had a layover at an airport. The Aletsch Glacier's terminal moraine in Switzerland is a striking example of glacial activity in the European Alps. This moraine, located near the glacier's snout, marks the furthest advance of the glacier during colder periods in Earth's recent history, such as the Little Ice Age. Moraines form as glaciers push and carry debris, like rocks, soil, and sediment, downhill, depositing it in ridges at their edges. Over centuries, as the Aletsch Glacier advanced and retreated with changing climates, it left behind a massive terminal moraine, creating a record of its historical movements. Today, this moraine is an important feature for studying past glacial activity and understanding the impacts of ongoing glacial retreat due to climate change. One of the most famous landforms in America is the Grand Canyon. But was it created by glaciers? Glaciers had an impact on the Grand Canyon, though they were never actually in that area. The Grand Canyon is a breathtaking natural wonder in Arizona. It may not have glaciers today, but its formation is linked to ancient glacial activity. During the ice ages, massive glaciers formed in the nearby Rocky Mountains, influencing the flow and strength of the rivers like the Colorado River. These rivers, swollen with glacial meltwater, carved through layers of rock with immense force over millions of years, deepening and shaping the canyon into the iconic landscape we see today. Although glaciers never directly covered the Grand Canyon, their distant presence played a crucial role in its geological history, serving as a reminder of how interconnected Earth's systems are. Scientists can learn a wealth of information information from glacier core samples, which offer a glimpse into Earth's past climate, atmospheric conditions, and environmental changes. By analyzing ice cores extracted from glaciers, researchers can study trapped air bubbles that contain ancient atmospheric gases like carbon dioxide and methane, providing direct evidence of past temperatures and greenhouse gas concentrations. These ice samples also contain dust, pollen, volcanic ash, and other particles, which reveal information about past natural events, such as volcanic eruptions or shifts in vegetation. Additionally, the layers of ice in glaciers act as a historical record, with each layer representing a different year, allowing scientists to study the growth and shrinkage of glaciers over time and assess the impacts of climate change. Glacial samples can also reveal the presence of contaminants like heavy metals, offering insight into human activities and pollution over centuries. What are some other things that you think might be waiting in the ice for scientists to discover? Glaciers are more than just icy monuments. They are crucial for life on Earth. They store about 70% of the planet's fresh water and act as natural reservoirs, slowly releasing the water into rivers and ecosystems. The Indus River in South Asia, originating from glaciers in the Himalayas, provides water for agriculture and drinking to regions in India and Pakistan. Similarly, the Colorado River in North America, which is fed by glaciers in the Rocky Mountains, supplies water to arid regions in the southwestern U.S., including major cities like Las Vegas and Los Angeles. Millions of people rely on glacier-fed rivers for drinking water, farming, and electricity. Glaciers play a vital role in supporting animals and ecosystems, both directly and indirectly. They provide fresh water to rivers and streams, which serve as crucial habitats for fish, amphibians, and other aquatic life. In polar regions, glaciers create unique ecosystems that support species like polar bears, seals, and penguins, which rely on icy habitats for hunting, breeding, and protection. Glacial meltwater also nourishes downstream forests, wetlands, and grasslands, fostering biodiversity and supporting migratory bird populations. Even as they melt, glaciers contribute nutrients like iron to oceans, stimulating plankton growth at the base of marine food chains. Glaciers are integral to maintaining biodiversity in cold climates. Glaciers play a crucial role in regulating global temperature through the process known as the albedo effect. Their icy surfaces reflect a significant portion of sunlight back into space, which helps to cool the Earth's surface. The high reflectivity of glaciers, particularly in polar regions, prevents excessive heat absorption by the land and oceans, helping to maintain colder temperatures in these areas. This cooling effect is especially important in the context of climate change. As the melting glaciers decrease, their ability to reflect sunlight decreases, causing more heat to be absorbed by the Earth's surface, which in turn accelerates global warming. By maintaining the albedo effect, glaciers help stabilize the planet's climate. But glaciers are in trouble. Climate change is causing them to melt faster than ever before. Since 1900, glaciers worldwide have lost more than half of their ice. This contributes to rising sea levels, which threaten coastal communities and ecosystems. Even small changes in temperature can have a big impact on glaciers. If we don't act, many of the world's glaciers could disappear over the next century. The good news is we can make a difference. While glaciers are rapidly melting due to climate change, there are steps we can take to slow their decline and protect our planet. Reducing carbon emissions by using cleaner transportation, improving energy efficiency in buildings, and switching to renewable energy sources like solar or wind are essential measures. Supporting organizations that work to protect glaciers, such as those focused on environmental conservation and climate advocacy, is another powerful way to help. Additionally, even small actions like conserving water and energy at home, reducing waste, and spreading awareness about the importance of glaciers can have a significant collective impact. By making sustainable choices in our daily lives and encouraging others to do the same, we can help protect these vital natural resources for future generations. Now, let's learn some fun facts about glaciers. But first, let's create some glacial landforms on YouTube by liking this video. Liking, commenting, and subscribing really helps me to keep making educational videos. Thank you so much for the support, and now to the fun facts. Glaciers actually flow like a very slow river because of the pressure and gravity acting on the ice. Glacier ice isn't white. While glaciers often appear white, the ice can sometimes be blue. This happens because the ice absorbs red and white light and only reflects blue wavelengths, especially when it is very dense and free of air bubbles. Although glaciers often appear white or sometimes blue, the ice itself is clear. The color we see is due to the way the light interacts with the ice, especially as it's compacted over time. Glaciers are not unique to Earth. Scientists have discovered glaciers on Mars, Venus, and even on moons like Europa, which has ice-covered oceans beneath its surface. Glaciers drink carbon dioxide. Glaciers absorb carbon dioxide from the atmosphere through a process called carbon sequestration, where the ice and snow can trap this greenhouse gas and prevent it from contributing to climate change. Inside glaciers, the ice can form stunning caves, which are often brightly colored and have smooth, sculpted walls. These caves are formed as meltwater seeps through and carves channels inside the ice. Glaciers are ancient. Many glaciers are thousands of years old. The ice in many glaciers in Antarctica can be up to 1 million years old, having been compressed and compacted over millennia. I hope you enjoyed learning about glaciers. Glaciers are more than just ice. They're storytellers of our planet's history and guardians of its future. By understanding them, we can help to better protect them and the life that they sustain. Thanks for joining me on this frosty adventure. Don't forget to like, subscribe, and let me know in the comments your favorite fact about glaciers. Parents and teachers, if you're teaching about glaciers, click the link in the description for a resource that might be helpful to you. Thank you for watching, and as always, don't forget to get messy and make lots of mistakes today. Bye!